So electrification of the Navy is important because global navies, and the US Navy in particular, are starting to come to the realization that the benefits that have been seen in the commercial world for a long time are now useful to them. But the commercial world has been most interested in efficiency and packaging ability and superior dynamics mainly, whereas the navies have tended to be less interested in efficiency. However, efficiency, of course, helps the Navy because it allows for longer on-station time, longer duration, longer mission times, and there are other benefits as well. And some of these benefits are becoming more prominent now, as there is a drive to in general towards electric weapons and sensors. An electric drive propulsion system integrates much better with that. It's much easier to be able to offer laser defense if you're using a battery energy storage system or some kind of other energy storage system that can then integrate in with a propulsion system to perhaps charge it or to pass power around the ship. Other benefits the Navy can see are superior packaging, which allows better damage control around the ship, and of course it helps having efficiency as well in those kind of circumstances. So electric drive isn't new. It's been around a long time, actually. As long ago as I think 1918, there was a French cruise ship that was made with an electric drive. However, it kind of fell out of favor over the years, and really with navies, because essentially they want to have the most compact and most reliable systems, and those tended to be mechanical propulsion systems using gas turbines, for example. A straight shaft through the ship, a very compact power-dense engine, providing instantaneous power. And electrification, although it's been around a long time, it really wasn't until the 1980s and 90s that vector control of variable frequency drive systems really matured enough that you could get really accurate control of electric motors. So that was probably the turning point in the late 80s, early 90s. And the commercial world picked it up first, maybe with cruise ships and other kinds of applications. And then more recently, battery energy storage systems have come into play. They really weren't around for the longest time. The commercial world has used those and integrated those as well. But of course, they also have the benefit that they are very good for pulsed energy surges and the like. So if you add them into an electric drive system, it becomes very attractive for a naval application. So one thing about electric drive systems is that the shipyards and the primes that tend to build ships are not very familiar with them. They're very familiar with mechanical systems, not so much with electric systems. And they can be complex. They can be more complex from a control point of view. You get a lot of benefits in terms of control, but much more complicated in terms of control. So what we're seeing is that shipyards are after integrators, much more than they were, electric propulsion system integrator kind of role. And that's something where DRS can really offer something valuable. With our long experience with both surface ships and submarines as well, we have a lot to offer in that area in terms of integration, whether it's integrating our own equipment or integrating other packages of equipment and control systems. DRS has been in the Navy game for a long, long time. DRS has equipment and systems on every major US Navy platform since the 1920s. So as technology has moved along, DRS has really been at the cutting edge of that at all times. And that includes electric drive propulsion systems as well, and control systems that go with them. We've been doing it a long time, maturing the technology, and doing it arm in arm with the US Navy. And that technology is now available for export as well to other navies.